PASS. We're part of the PASS organization. And let me start the slideshow. By the way, can everybody see my screen? I'm talking and talking. Kevin?
Yeah, I can see your screen fine.
Okay, awesome. If you can, then everybody can. So, yeah, PASS community news. The summit is next week. If you haven't registered, too bad. All the good hotels are sold out, and I did not as well. But I managed to find a nice Airbnb and registered at the last moment. So if you haven't, you still got a chance to do it. And although the price is full, we'll send you the discount code, which for some reason has disappeared from the slide, but I'll get it to you later. So if you're interested, shoot me an email and I'll send you the discount code for the PASS Summit, $150. Send it to imvc@sqlpass.org. That's the virtual chapter's address. So yeah, as you know, we are a virtual chapter. We try to meet once a month, but we're only one chapter out of a huge number of chapters, and there's more coming every quarter. So no matter what you care about, what you're interested in, there's definitely a virtual chapter for you out there. So look it up, sqlpass.org, go to the virtual chapters, and by all means join. It's completely free, as you know. You get top speakers from all over the world. Just enjoy it. Here are a couple of selected virtual chapters meeting that are happening this month. This is just a partial list. Of course, if you go to the SQL Pass website, you will find the complete list with all the speakers, all the topics for all the virtual chapters. But as you know, PASS is not just about virtual. PASS also has SQL Saturday, which is a full day free training event in person. And this upcoming SQL Saturdays, so the Charlotte and the Boston have already taken place, but the Oregon one is just coming up. And there's one in Mexico City coming up. And again, go to sqlsaturday.com and there's bound to be an event near you. If you don't know, all PASS is a volunteer organization, and without volunteers, none of this would have been possible. So we do also encourage you to join and contribute to the community. The easiest way to do it is typically part of your local PASS chapter. There are PASS chapters, not the virtual ones, the physical ones that take place all over the world, and they provide lots of benefits for yourself, for your career, and it's just a lot of fun. And if you're willing to contribute back and give back to the community, just contact your local PASS chapter and I'm sure we'll find opportunities for you to participate. Also, you can, if you want to volunteer for the summit, if you want to do volunteer online, go to volunteer.sqlpass.org, fill in your details, and somebody will get back to you with volunteering opportunities. Yeah, this was okay. They made the whole slide clickable. Okay, anyway, I know you didn't come here to listen to me speaking about PASS, so I'm going to hand things over to Kevin. Kevin, you ready?
Yes, I am.
The screen is yours. Go ahead.
Okay, I just took the option to share my screen. So first of all, just a real quick audio video check. I assume you can hear me fine. And can you see
muted?
Can you see my screen? Okay.
Yes, I can see your screen. Okay, and we'll assume that everybody can as well. By the way, you have since you're all muted. Attendees, the voice doesn't work, but there is a chat window, and you can use that if you have a question. We'll make sure Kevin has a little bit of time at the end to answer questions.
Okay, great. Okay, well, let's get started. Thank you all for attending. My name is Kevin Goff, and the topic for today is 13 productivity tips for in-memory OLTP enhancements in SQL Server 2016. Nice long title there. Now, some of you might be readers of Code Magazine. Code stands for Component Developer Magazine. I've been writing for Code Magazine pretty much regularly since 2004, and I've had a series called the Baker's Dozen Productivity Series, where I present 13 different tips, usually on SQL Server business intelligence topics. Code Magazine is known more as being a .NET developer magazine, but they do have database content, and I've been writing database and BI content for a long time. And so a lot of the presentations, webcasts, use that same theme of 13 productivity tips. Very quick bio on me. We'll get into the details here in just a moment. I'm in the SQL Server MVP program. I've been an MVP since 2005. I speak up and down the Mid-Atlantic. As a matter of fact, the presenter just mentioned, the organizer just mentioned the SQL Server Saturday in Boston. I was actually up in Boston this past weekend for the SQL Saturday event. If you've never been to a SQL Saturday event, I highly recommend that you try to check one out. You can go to the SQL Saturday site and see the different events that are coming up. Highly recommend it. The only thing you need to write down here is my email address on my website. My email address, if you want to send me an email afterwards, is kgoff@kevinsgoff.net. And my website is www.kevinsgoff.net. In my download area, I have several slide decks downloads for other SQL Server business intelligence topics. Feel free to pull down anything that interests you. I also have some webcasts up in the webcast area of my site. Now, by the end of the day, this slide deck, as well as the code samples, will be up on my site. The most recent version of my slide deck is, I didn't get it up there before this presentation started, but I will get it up by the end of the day, I promise. So, just as an overview, this is an introductory session, and it assumes no specific knowledge of in-memory OLTP databases, and you want to learn more. However, I'm going to talk a little bit about what Microsoft has done moving from SQL 2014 to SQL 2016 with this new feature. Now, SQL 2016 is not available in production yet. It is in CTP form, and I'm using the most recent CTP that's available, but there may very well be additional CTPs that come down the road at a later date before Microsoft finally releases this. But we're working with the CTP right now, so things are certainly subject to a change. But there's definitely enough in the most recent CTP for SQL 2016 for people to see what Microsoft is doing with in-memory OLTP as well as a lot of other features. Now, I'm going to go over some demos of how in-memory OLTP works to potentially boost performance in certain scenarios. And I'm also going to talk about what in-memory OLTP doesn't do or isn't for. It's certainly not going to be used for every database scenario around, so it's very important to know where it's going to work well. So, in my standard Baker's Dozen 13 tip format, here are the items that we're going to look at today. Now, given that we have an hour, the last couple of topics I might just speak to very briefly at the end, but obviously you can pull down the slide deck. I've got some notes in here, and you can certainly contact me if you have any questions. So we're going to look at what is in-memory OLTP, when should we use it, some demonstration benchmarks, creating in-memory OLTP databases, some of the index options, how OLTP tables differ from normal SQL Server tables, the supported data types, some of the terminology that we're going to look at along the way, like bucket counts that you may very well run into if you're going to create indexes on in-memory OLTP databases, and then some information on the end about store procedures and using in-memory OLTP with other SQL Server features like table types. So let's get started with the items. First of all, what is in-memory OLTP? Well, a little bit of history. This was created first in SQL Server 2014 in the Enterprise Edition. So that's the first thing to be aware of right off the bat. In-memory OLTP is only available in the Enterprise Edition of SQL Server. It's been significantly enhanced in SQL Server 2016 Enterprise. As I'm going to go through, I'm going to talk about where Microsoft has enhanced in-memory OLTP and beyond just getting information on the specific areas where they've addressed. The general message that definitely comes out of Microsoft is that they have paid very close attention. They've really committed time and resources to making in-memory OLTP better in 2016, and a lot of people are very pleased with what Microsoft is doing. In-Memory OLTP is an optimized row format for specific tables where we want to get the absolute highest level of performance, and where we are satisfied that the data can just simply stay in memory. It doesn't necessarily need to persist to disk, or might persist to disk in certain scenarios. So we can't use this for every scenario, but certainly we can use it for a lot of them, and I'm going to talk about those scenarios here in a few minutes. And we can get potentially several times better performance than using standard tables. Just like Microsoft rewrote some of the database engine, created a new buffer pool for dealing with things like column store indexes, Microsoft has also created a new buffer pool that targets this new in-memory optimized structure. So we've got a whole new space within the database engine specifically for this. Now, you can still access in-memory OLTP with T-SQL statements, as we're going to see. There are some limitations, but you can still use standard T-SQL statements to operate on in-memory OLTP tables. Now, in-memory OLTP tables derive performance benefits from several different architectural changes that Microsoft has made. One of them is the fact that there's no row locking, or some people would say locking and latching. Those are both logical and physical operations and objects dealing with concurrency and with isolation levels with normal tables. Those don't exist within memory OLTP. It utilizes optimistic concurrency instead. So as a result, there's less overhead associated with it. Now we can create, as we're going to see in my examples here in a few minutes, a couple of different types of indexes within memory OLTP tables. They are called hash indexes and range indexes. We'll get to them in just a few minutes and what they mean. They're going to be utilized for different scenarios. Hash indexes for specific lookups on specific key values like a purchase order ID, whereas a range index you might use for something like dates. Now, in-memory OLTP, another term that we'll become familiar with is what's called the storage or the durability mode. That's basically, how is the data going to persist? There's essentially two options. There is schema only. Schema only, it means that the data is purely in server memory, that there's no I/O that's going on at all. As a matter of fact, if you look at I/O statistics on queries against in-memory OLTP tables that use schema only, you're not going to see any I/O statistics because there essentially aren't any. Now, we can also persist the data to a file stream, and so there's a second option for schema and data. Essentially what that means is that if the database engine goes down, if the service goes down and you bring it back up, if you're utilizing schema only, the data is going to go away. So you would only use schema only for situations where if the server goes down, you don't care. Staging table is going to be one option. But if you need the data to persist, like very large static lookup tables, then schema and data might be a better option. So the point is that Microsoft has baked a lot of functionality into the database engine and into this new buffer pool, and so as a result, there's lower overhead, there's much better CPU utilization, and there's faster performance with these types of tables. As we're going to see when we get into specifics, there are index restrictions that existed in 2014 that Microsoft has largely lifted in 2016. Now, not all applications are going to be able to use this. You definitely have to think about strategy when you implement in-memory OLTP, and the same thing goes for things like column store indexes. Certain scenarios, certain tables are going to benefit from these more than others. So we'll get in the specifics here in just a moment. So as I said, not all applications are going to benefit from in-memory OLTP. Now, by the way, there was a term that was used when this was introduced in SQL 2014. In-memory OLTP was known as Hekaton. So if you ever see any websites that talk about Hekaton, Hekaton was the name for in-memory OLTP in the early stages of SQL 2014. You don't hear Hekaton used too much anymore. It's simply referred to as in-memory OLTP, but Hekaton is just a reference to when it was first created. So the best application scenarios or segments where we can use in-memory OLTP. At the top of the list, in my opinion, staging tables in ETL scenarios. Classic example, we might read data from an Oracle system or from a DB2 system or maybe from a legacy SQL Server system, and we don't necessarily want to read it directly into a data warehouse or a data mart or some operational data store. We want to read it into a set of temporary tables or what we might call staging tables, turn around and run additional queries on the staging tables, or validations or groupings or whatever, and then load those into the final destination. Well, staging tables are a great scenario for using in-memory OLTP because we don't need to persist the data. It's going to be significantly faster than using standard tables. Holding SQL Server session data with web applications. If you've got scenarios where you need very, very fast inserts and reads, where you're in a heavy environment where you've got heavy inserts and maybe heavy random reads, utilizing in-memory OLTP tables is going to give you better performance. Bulk inserts and sometimes bulk updates are going to benefit from in-memory OLTP. We're going to get performance gains of 2 to 3 times and sometimes maybe even faster. And finally, some reporting applications and possibly some OLAP scenarios might benefit from in-memory OLTP. That's going to be one of those, it depends on how frequently you're updating data, what processes update data, what processes are going to be reading from the data to build OLAP cubes. So some people might be able to utilize it, some people might not be able to fully utilize it, but the point is that reporting applications in some OLAP scenarios might have situations where you might be able to use in-memory OLTP. Now, a question that comes up about in-memory OLTP, and we're going to get to some demo examples here in just a second. Question that comes up, Microsoft has created the column store index that actually started in SQL 2012 and that has been enhanced along the way. And then they've got the in-memory OLTP database capability that was introduced in 2014. The question is there overlap between these two? Can you create a table that utilizes both? Well, that's going to be, and it depends on whether you're using 2014 or 2016. In 2014, the answer is not really. They're two great features, but they really had different uses. Column store indexes were really more for data warehouse, data mart fact tables, for queries that scan and aggregate over a large number of rows. So you might utilize column store indexes for certain fact tables and certain data warehouses, but you would typically, if you were going to use in-memory OLTP at all in 2014, it would probably be for dimension tables if you would use it at all. And there were some restrictions. First of all, you couldn't combine the two. You couldn't create a column store index on an in-memory table. And despite all of the performance benefits of the column store index in both 2012 and 2014, if you would join a table with a column store index to an in-memory OLTP table, you would lose some of the performance benefits that you would get out of a column store index. I'm going to talk about that in a few minutes because that limitation has actually been lifted. So in 2016, is there overlap between the two, or are there potential to use the two together in ways that you really couldn't do it optimally before? The answer is quite possibly yes. First of all, as we're going to see, you can have a table that is both in-memory OLTP table and has a column store index. So you might conceivably have a fact table with a column store index, with a cluster column store index, and be built as an in-memory OLTP table. Certainly going to need the necessary memory on the server to do so, but it is possible. And you can also join the two tables together and get the benefit of some of the performance capabilities of the column store index, like batch mode, which leaves opportunities for parallelism. So, going to take a look at some demonstrations. That's what everybody came here for, and going to look at some examples. So, I'm going to open up Management Studio. I've actually got Management Studio 2016, the most recent CTP loaded. And I'm going to start by creating a database that is going to permit in-memory optimized tables. So I'm going to right-click on Databases, and I'm going to create a new database. And I will call this Pass Demo 2016. Now, what I need to do if I want to create a database that's going to have in-memory optimized tables in it, what I need to do is I need to go down to File Groups. And under File Groups, and this was basically the same thing in 2014, there's a section down here for memory optimized data. I'm going to create a file stream that's associated with that, so I'm going to add a file group at the bottom, and I'll just simply call this MOD for memory optimized data 2016. And now that I've created that file group, I'll come back to the general area and I will add a reference to that database file. So I'll click Add down at the bottom under the general area, and I'll give it the same name here. What I called it MOD 2016. I'll call it the same name here. And for the file type, I'm going to specify that that file stream that was created as a result of that memory optimized database. So I've got the file group there of the same name, MOD 2016. And for purposes of this demo, I'm just going to keep the defaults here. So I've created a database in the file group area. I added a file group of type memory optimized data, and then reference that as one of the database files for this database. So I'll take OK, and that creates a new empty database called Past Demo 2016. Now I'm going to populate and going to look at some examples here in a second. I've got a script file, and I will bump up the font here a little bit so that everybody can read it. And I have to use the right name here, so that's going to be Past Demo 2016. And I'm going to create a couple of tables here. Now, first of all, I've got a spreadsheet that is sitting out on one of my folders on this machine that has about 10 million rows of dummy purchase order IDs, vendor IDs, product IDs, order dates, and dollar amounts. So I've got a spreadsheet, the CSV file that's sitting out on my machine that I'm going to load into here in just a moment. So I'm going to create 3 tables. The first table is just going to be a regular SQL Server table. I'm going to call it Stage Purchase Orders Regular. It's going to have a purchase order ID, a vendor ID, a product ID, an order date, and the total due. So I'll just create this table. By the way, another little enhancement that Microsoft added in 2014, you can specify indexes in line in the DDL2 to create a table. So I just created a regular table. Well, now I'm going to create 2 in-memory optimized tables. And one I'm going to call Stage Purchase Order Second SO for schema only, and another one Stage Purchase Order Second SD for schema and data. Now, the only difference between the 2 of these is going to be the durability mode. We get some new syntax here at the bottom. This is relevant to both 2014 and 2016 to designate this table as an in-memory optimized table. So one is going to be schema only, which means that it is purely in memory. There's no data being persisted to any disk, any file stream at all. So I'll create this, and I've intentionally left the total due column out because I want to talk about being able to add to the structure after the fact. So I'll create that table. And by the way, a note here as I'm going along, I'm running CTP of 2016, and I'm running it on a machine with 8 gig of memory, and I'm going to be bouncing back and forth between 2016 and 2014. So it should go without saying that even though I've scripted this demo at the beginning, and it should go fine, there's always a possibility that I might hit some kind of system error or something. I might have to just turn off the service and turn it back on. So with that little provision, I'm going to create the same table here again, but this time with the durability of schema and data. Now both of them are empty. Now a couple of things here. First of all, I left out the reference to total due. I intentionally left out the reference to total due in both tables. The reason that's significant here is that in 2014, if you created an in-memory table and you forgot a column, you essentially have to recreate the table. You could not issue any kind of alter table statement on an in-memory optimized table in 2014. Very, very, very serious restriction. You'd have to obviously create the table again and load into it from the original table. No ability to do an alter table. Well, here it's much easier. I can do an alter table, and I can add the 2 columns. So something new in, actually, I should say couldn't do this in 2014, but we can now do it in 2016. So I'll alter the table. Now one thing about that, if there had been data in both tables, SQL Server is essentially doing that quote-unquote offline, which means that you'll have to have plenty of space and memory to be able to do that. So that's the one provision of doing an alter table. If you have a database, an in-memory optimized table with a lot of data in it, you're going to need to have the necessary resources in order to do so. Now another thing that we couldn't do in 2014 that we can now do in 2016. Let's come back up to either one of those tables, specifically the schema only table. Notice how when I created the purchase order ID, I specified as a primary key, and I've got this new syntax called non-clustered hash with bucket count of whatever. Well, what does this mean? Well, essentially, in-memory optimized tables allow you to have hash indexes, which are going to be particularly helpful to do very, very fast lookups on single key values. So we can create hash indexes. Now, there's two things about hash indexes. First, they can only be non-clustered. You cannot right now have a clustered index on a hash index in an in-memory optimized table. Second thing is there's a bucket count. If you know anything about the history of hash indexes, we need to specify a bucket count associated with it. Now, as I'm going to point out in just a little while in another bullet point in my slide deck, Microsoft's recommendation for the bucket count is going to be anywhere from 1.5 to 2 times the number of unique values that you're going to have in that table. Now I'm reading in a table with from CSV file with 10 million entries in it, 10 million unique purchase order IDs. So I'm going to specify a bucket count of 15 million. Microsoft's recommendation again is at least 1.5 to 2 times. But as you can probably imagine, a challenge with that is bucket counts are not going to be static. You're going to get more data into your table at any one time. So, how would you adjust a bucket count? Well, once again, in 2014, you couldn't alter the table to change the bucket count. You were restricted with what you had, and if you needed to change the bucket count, you would have to recreate the table. Certainly not impossible, but not a very great scenario. Well, in 2016, we can now do this. We can alter the table and alter the index, rebuild the index with a new bucket count. So I intentionally made the bucket count 10 million here just to demonstrate that I can bump it to 15 million. So execute that. Now, I made a little mistake here. When I created the index, I didn't specify a name, so I need to grab the exact name here. So I'll expand tables and expand my schema with data definition and go down to indexes, and I didn't give it a good name to begin with, so I have to go grab the name that SQL Server generated. And I'm going to alter that table, I'm going to alter the index and rebuild it with the bucket count that I want. And it would help if I pointed to the right database. So my apologies there. Pick the right index. And execute that. And now I have done what I couldn't do in 2014, which is to rebuild the index with the correct bucket count. All right, well, let's get some data into these tables. I'm going to go over to SSIS, and I've got a package that's going to take about a minute to run, so I'm going to talk about a few things while it's running. I've got a package that's going to populate all 3 of those tables with a 10 million row CSV file. Now the package itself, and I need to adjust something here because I think each one of these is missing a column. Oh, actually, you know what? I changed I changed the database name here, so it's not it's actually not demo 2016. It's past demo 2016. So that should correct all of those. All right. Each of these data flow tasks is essentially the same. I'm going to read from a 10 million row CSV file into each of those 3 tables. The regular SQL Server table, the in-memory optimized table that utilized schema with data, and the in-memory optimized table that utilized schema only. Now the numbers can vary at any one time, but just to give you a general idea, populating 10 million rows on my machine, 8 gig of memory, is going to take about 72 seconds with the regular table. It's going to take about 31 seconds with the schema with data durability mode, and then 27 seconds for the purely in memory where it's not tethered to any kind of file stream at all. So right off the bat, we see that we get at least 2 times the performance benefit using SSIS and a data flow to populate the other tables. So I'm going to execute this task, and I'm going to come back and talk while that's running because that's going to take about a minute. So let me come back to my code here. What I'm going to do in a minute after these tables are populated is I'm going to run a couple of queries against all 3 tables. the regular table and then the two tables where I utilize schema only and schema with data, and take a look at both at the I/O statistics and the amount of time it takes to run these, as well as the query costs. And I'm going to do it both for the key column that we use for the hash and the order date column that we use for the range index. And come back to here. This should be done in just a second or two here. So I'll come back to my code here. So I'm going to take a look at the I/O statistics and the execution costs for both of them. Now, another point I'm going to make here in just a second. When I do a count on all three tables after I populate them, I'm going to get 10 million rows. But remember, one of them I designated purely as in memory, so that the durability mode was schema only. There's no synchronization to a stream of data through file stream at all. So if I were to restart the SQL Server service and then run this query again on the table that designated schema only, I'm going to get 0 for the record count. It is purely in memory. Okay, that one's actually taking longer than normal, probably because I rebooted and rebuilt the database. So just continue to talk here. About another point that I want to bring up is statistics on in-memory optimized tables are not automatically updated. So if I want to get the best performance out of queries going against these tables after a load, I'm going to want to run update statistics on both the schema with data and schema only table. So let me come back to here. Wow, that is really still trucking here. So I'll come back to my slide deck here for just a second and talk about a few more benchmarks. Again, the numbers are going to vary, but we can expect to get 2, 2.5, sometimes even 3 times performance, and other scenarios with more memory, people might get even better performance. Now, I'm also going to do a bulk insert of data from a CSV file. I'm going to get similar performance gains utilizing either of the 2 durability modes within memory optimized tables. So again, staging tables are a great use for this. So coming back here, okay, that finally finished. Probably because I rebooted. That actually took 2 minutes. So that was actually the worst time I've ever had here. So hopefully the second and third will go much faster. So I'll run the schema and data option. I right-click and execute this. Now hopefully that won't be much more than 31 seconds. It will definitely be faster. Again, I rebooted and rebuilt the database, so definitely starting cold here. So after this is finished, after I'm finished populating all 3 of these, I'm going to run queries against both the key columns and that was specified for the hash index, and then the order date that was specified for the range index, and we'll get an idea of the comparisons between queries against the other 3 tables. We're going to see that the cost against the regular SQL Server table is going to be significantly higher than the cost for either one of the in-memory optimized tables. So it's still running here. Okay, that one finished, and that one took 51 seconds. So compared to 2 minutes. So again, I'm starting cold here. So I will stop debugging there, and then I need to execute this one. Hopefully this will be the fastest of the 3. This is utilizing schema only. So this one is going purely into memory. There's no association with any kind of a file stream, so this should be the fastest of the 3. So 2 minutes and whatever seconds versus 50 seconds, still definitely more than 2 times faster when reading in 10 million rows. So just as soon as this finishes, I'm going to update the statistics, and then I'm going to take a look at some queries here. And then the next demo we're going to take a look at in a minute is going to utilize the column store index in association with the in-memory optimized tables. So we'll wait for this to run. And that one finished, and that one was 47 seconds. So that was getting anywhere from just a little over 2 times to almost 2.5 times faster. All right, so I'll stop debugging there, and I will come back, and I'm going to want to update statistics on both of my tables before I run any queries. Again, this has to be done manually. We need to update statistics with a full scan on both tables before we want to do any kind of serious benchmarks across all 3 tables. So as soon as those statistics are updated, going to actually take a look at a query against just a specific purchase order ID and get an idea for the difference in performance and in query cost. So just as soon as those are finished. So I realize it can take you a few seconds, but I wanted to get a good size table in here. Again, we're dealing with 10 million rows, trying to simulate something that's real world in terms of the amount of volume. 10 million is not the biggest staging table that you're going to see in the world, but it's not exactly child's play either. All right. Well, I'm going to turn on the execution plan, and I'm going to set IO and time statistics on. And I'm going to run the same query. I'm going to make the schema only table go first. I'm going to make the regular table go last. I'm going to let that one go last. Now, obviously, a query against just one purchase order ID, they're all going to come back pretty quickly. But let's take a look at the execution plan here. Now, execution plans are not, even the actual execution plan is not an absolute set in stone number. These are still approximations, but when you see numbers that are this big of a range, it's certainly significant. The query cost for either one of the two utilizing in-memory optimized tables was 1% compared with 99% for the third. And now notice how we're getting an index seek on all three. We're getting an index seek on the hash index for the first two, and then an index seek on the clustered index for the third. So the cost for the first two is just a tiny amount compared with the cost of the third. Let's go to the messages and let's actually take a look at the elapsed time. The elapsed time for the first one for the schema only was 18 milliseconds. For the schema with data was 109 milliseconds, and then for the regular table was 908 milliseconds. Now again, 908 milliseconds, that's 9/10 of a second, but still, that's significant. If you can imagine utilizing session data where you're going to be doing heavy random inserts and reads throughout the day, imagine getting that kind of a benefit in performance. Those little areas of web pages where you might have a slight amount of sluggishness can possibly be addressed by utilizing memory optimized tables with session data. So that's significant right there. All right, now I'm going to take a look at the range index. Now the range index, we're not going to get nearly a factor of 99 to 1, but we're still going to get some pretty significant numbers here. I'm going to query the three tables on a range of months from October 1st to October 31st of 2005. So I had a range index that I built on the order date when I created all three tables. I'll execute this, and I need to wait for all three to run. Takes a few seconds because that's bringing back a couple 100,000 rows per query. So that's finished. I'll go to the execution plan. And the two queries that utilize in-memory optimized tables, either schema only or schema with data, were 10% and of the cost, and then the query against the regular table was 79%. Now, SQL Server recognizes that in order to bring back data from a non-key column for a range index, it's obviously got to scan the clustered index or possibly do a seek into the index and then do a record lookup into the heap or into the clustered index to get the rest of the non-key columns. So the database engine here is smart enough to realize that a covering index where the key is the order date but includes the other columns would benefit there. So admittedly, a covering index would in all likelihood outperform the range index on those two in-memory optimized tables. That's certainly understandable given the circumstances. But as it is, without a covering index, the two range indexes and the two in-memory optimized tables are going to run faster. Okay. Now, if I do a count on all three of these tables, I'm going to get 10 million on all three of them. Now, I'm not going to do this. You just have to take my word for it. If I were to go out, restart the SQL Server service, come back in, and query this again, the count for the second table, where I utilize schema only, is going to be 0. Tables that we create with the schema only designation, let me come back up to where I created the table. When we created the table that I called SO for schema only, where the durability mode is schema only, that is purely, absolutely purely in memory. There is nothing that's being synchronized with any kind of streaming information on disk. So you bring the server down, or if the server goes down for any reason, you're going to lose that data. Now, again, depending upon what are we doing with staging tables, you may not care. Okay. Well, I'm going to come down to the second demo here, and I'm going to essentially create the same tables. Now, before I do, I'm going to actually get rid of the first set of tables so that I don't. I'm restricted on memory here on my machine. I've only got 8 gigs, so I'm going to drop these first 3 tables here so that I don't lose any memory. I'm going to drop those 3 tables, and I'm going to save this. I'm going to close Management Studio for just a minute. I'm going to close Visual Studio, and I'm actually going to go into my Configuration Manager, and I'm going to stop the service and turn it back on. Again, I just want to get as much memory back as possible before I go on to the next step here. So I'm going to stop the 2014 service, and I'm going to restart it. And I will launch Management Studio again. Oh, excuse me, not that. I want to launch Management Studio again. And I'll pull up my demo script and bump up the font again. All right, now we're going to take a look. I'm going to create, essentially going to create the tables again, but this time I'm going to call them bulk purchase orders. So I'm going to create that same structure of a purchase order ID with a hash index, a vendor ID, a product ID, an order date, and a total due column. So create each of those tables via the schema only table and the schema with data table. All right, and I'm going to do a bulk insert. Now I'm only going to do it on one of the tables. I'm going to do it just on the table schema with data. Now, in this demo, I actually capped it at 5 million rows. So I use first row equals 2 to not bring in the header row from the CSV file that I'm using, and I'm going to stop at 5 million rows. When I do this, the bulk insert from a CSV file takes 22 seconds with a regular table, takes 10 seconds on the schema with data table, and takes 8 seconds on the schema only table. So again, we're getting performance gains of at least a factor of 2, and sometimes a little bit better than a factor of 2. I'm going to do it just on the one for schema with data. So I'll execute this, and that should come back in about 10-12 seconds or so, hopefully. And going to do something with the data once that table is loaded. Okay, that ran in about 15 seconds, so a little bit longer than normal. Now, I'm going to create a second version of the table and read in data from the first. I'm going to do something you could not do in SQL Server 2014. I'm going to create the same structure as an in-memory optimized table with the durability being schema and data. And I'm going to specify a clustered column store index, because not only do I want to get the benefits of an in-memory optimized table here, I also want to be able to run very fast aggregations across the data in this table. You could not do this in 2014. This increases the number of scenarios where people are going to be able to utilize one or both of those technologies. So I'm going to create this table. So I've created an in-memory optimized table that also is utilizing a cluster column store index because I want aggregations on the total due to run much faster, which is basically what a column store index is going to give me. Now, right now that's empty. I need to insert that table with the cluster column store index from that bulk purchase table that I built with the 5 million rows just a moment ago. So I'm going to run the insert here. And that'll take a few seconds. It's inserting the 5 million rows from my bulk table into my table that's both an in-memory optimized table and one that has a column store index. Now I'm going to update statistics on both the purchase order header, the purchase order table that where I built as a bulk purchase order table using schema with data, and I'm also going to update the statistics on my table that has the column store index. So I'm going to update statistics on both of those. Actually, let me get the right table names here. Okay, so I did it on the one, do it on the other. And then what I'm going to do here, now that I've updated statistics, I'm going to run, if you've seen demos utilizing the column store index, you've probably seen some of this, at least in concept. I'm going to turn on the execution plan, and I'm going to query both tables, grouping by the vendor ID and aggregating the total due. The first one is going to be the in-memory table that had the column store index, and the second one is going to be just the in-memory table. Same query. And also set statistics on, and I'll run this query, run the same query. I'll execute this. Now this will take a few seconds to run because it's aggregating over a large amount of data, but we'll be able to see the differences between the two. So again, this is something that's new in 2016. I'll talk while this is running. The ability to actually create a column store index on an in-memory optimized table. And that's taking a little longer than normal, but we'll give it a few more seconds. Okay, it's finally coming back here. All right, I'm going to go take a look at the execution plan. And a couple of significant things here. Now, each of those queries brought back 104 rows, but it was aggregating over 5 million rows because that's the amount of data brought into that bulk insert. Take a look at the execution plans here. Now again, these numbers are not absolute, but anytime we see 7% versus 93%, then that's pretty significant there. Well, there's one thing I want to call to everybody's attention, and if you've seen demos with the column store index, you're probably already familiar with this. There's one big difference between these two queries. The first query that utilized the column store index is going to be significantly more efficient, and here's why. If I put the mouse over the execution operator that took the most time, it was the hash match on the aggregation. You might have remembered that when Microsoft created the column store index in SQL Server 2012, they added the batch mode. The batch mode essentially reads over the keys in that column store index. It reads over them as vectors in parallel blocks. It's essentially taking duplicate values, and in a fact table, you're typically going to have duplicate values for your foreign keys. It's actually treating them as vectors and reading them in blocks in parallel. So that batch mode is Microsoft's way of telling us in SQL Server that it's able to utilize the column store index to the full nth degree. By contrast, if I take a look at the hash match down here for the second one, that's using row mode. So even though that is still in memory, that second table was an in-memory optimized table, it's utilizing row mode. It's still going through one row at a time. So imagine a query that's able to read the data within that in-memory optimized table, read it as vectors in blocks of about 1,000 vectors at a time in parallel. Compare that with reading row by row, and you see why that first one is going to be significantly more efficient than the second one. Now, if I go to the messages here and take a look at the amount of time here, simply because we're dealing with a fair amount of data. The amount of time here for the amount of data I've got here wasn't significantly different. It was 1174 milliseconds versus 1586 milliseconds. It was actually taking most of the time to compile the other two queries. But still, the opportunity for parallelism here, because the SQL Server can utilize the batch mode, is going to make this potentially a much, much faster query than the second one. Now, there's a variation on this. Suppose we wanted to join together an in-memory optimized table with a column sort index. Suppose we had in-memory optimized table as a dimension, and we utilize a column sort index for the fact table. I'm going to close Management Studio here and open up SQL 2014. And in SQL 2014, I'm going to utilize the Contoso Retail database and bump up the font here. I've got a dimension here that I've called Hecaton dim promotion. It's just a promotion dimension that's tied to a fact table. Right now, there's nothing in it. I'm going to actually populate it from dim promotion. So I've got a regular dim promotion table that's just a regular SQL Server table, and then I've got an in-memory optimized table. This is in 2014 called Hecaton dim promotion. I'm going to once again run two queries that essentially do the same thing. They're going to sum up the sales, and this time group by the promotion, the value in the promotion dimension. The first time going against the regular SQL Server table, and the second time going against the Hecaton table. And I'm going to turn the execution plan on and run both of these queries. Now these come back pretty quickly. The execution plan here for the first table, for the first query that utilized the regular table, was 7% of the cost. The second one that utilized the in-memory table was 93% of the cost. They're both utilizing a fact table that has a column SIR index. That fact roll-up sales has a column SIR index. When we join it to a regular dimension, we get a query cost that's a fraction of the total cost of the two queries. When we utilize the in-memory optimized table in 2014, well, we get a much higher cost, and here's why. If I take a look at the execution operator for the hash match, the execution mode was downgraded to row. This was a problem in 2014. Again, it's a very specific scenario, but if you had a fact table with a column SIR index and you joined it to an in-memory optimized table used as a dimension, you would lose the batch mode that was so necessary in order to get the parallel execution of the query against that column SIR index. So we could only utilize regular tables if we were joining the fact tables at column SIR index if we want to get the really good column SIR index performance. That was in 2014. If I come back to 2016, and pull up my query again, down here I've got an example of a dummy dimension I'm going to call vendor master. So I'm over here in 2016. I'm going to create an in-memory optimized table as a dummy dimension called vendor master schema only. And I'll populate that with the vendors from my vendor master. So I'm going to populate that with what's essentially going to be 104 vendors. And now I'm going to join my table that is both the in-memory optimized table and has a column SIR index with a dimension that's an in-memory optimized table, so kind of overkill here. But the point is that unlike 2014, where joining an in-memory optimized table to a fact table that had a column SIR index would lose the advanced capabilities of the column SIR index, if I join these two now, turning on the execution plan, and come over here.
Kevin?
Yeah.
I just want to draw your attention that we have about 6 minutes left.
Right. Right. I'm gonna. Yeah. I saw the time. Yep. So thanks. We get, if I take a look at the hash match, the hash match execution operator, I now get that coveted batch mode, which again is going to give me the possibility of leveraging parallelism on the server if it's possible to do so architecturally to begin with. So the point is that we can now join in-memory optimized tables with column store indexes and get the true performance out of a column store index. All right, now I'm going to come back to my slides here. I've got 5-6 minutes left. That is essentially the core part of this presentation. The rest of this is going to be talking points. I may not get to all the points here, but I'll get to as many as I can. All right, moving on here. Something that was required in 2014 that is now no longer required in 2016. So I actually had this presentation from when I did this for 2014. I've kept the 2014 bullets in, but I put the red X through it to visually demonstrate the areas where Microsoft has addressed something. In 2014, if we had character-based indexes and you wanted to join them to other tables, you would need to specify a specific correlation sequence in order to do so. This was a big limitation or a big issue with some people. Now it's no longer necessary. If you have character-based indexes, you now no longer need to specify the Latin 1 general 100 bin 2 correlation sequence. But that was required in 2014 if you had character-based indexes. There's a new syntax for creating the in-memory optimized database if you wanted to actually script out the database instead of using the interface. Again, the new syntax contains the memory optimized data. We can alter a database by issuing the alter database DDL statement and specifying contains memory optimized data in conjunction with adding a file group. Again, the correlation sequences, we don't need to do that in 2016. When we create a memory optimized tables, you can create it in the interface now in SQL Management Studio, or you can script it out. Again, we can have hash or range indexes. With hash indexes, we have to specify a bucket count. The recommendation from Microsoft is 1.5 to 2 times the number of unique values you would have for that key representing the hash. A couple of other things that were limits in 2014. You couldn't have identity support. You had to use a sequence object, although actually at the tail end of 2014, they actually supported identity columns, but you had to specify seed value and increment value of 1, 1. So actually you could do identity support in 2014. They actually put that in the final release of 2014 after all the CTPs. No support in 2014 for having a column store index within memory optimized table, but you can do that in 2016. The durability mode, again, you've got options of either schema and data, which is the default, or schema only. Schema and data performs I/O in conjunction with file streaming with file groups, so the data is going to persist if the server crashes. Schema only, it is truly in memory. That's going to be great for staging tables, but obviously the data is going to be lost if the service is restarted. You get the ability to do hash indexes for specific single lookups on exact items, and you saw the performance a minute ago. Range indexes, we can specify in things like dates where we would, again, as the name implies, query on a range of values. Other limitations versus normal tables, some of which have been addressed in 2016. So the X's here indicate things that have been lifted. Identity columns, again, that's been changed in the final version of 2014 and in 2016. We can now specify column store indexes. We can actually have some DML triggers. You couldn't have any DML triggers on in-memory optimized tables in 2014. You now have some DML trigger capability in 2016. You can now have primary key, foreign key check constraints. There's still no support for a merge. You can now have support for varchar max. And again, primary key, foreign key, check constraints, and also at the bottom, the memory limitation. In 2014, you were limited to 256 gigabytes. In 2016, they've upped that to 2 terabytes. So for the really large-scale environments, in-memory optimized tables can be used when you have requirements to go beyond 256 gig of memory. Also, this was also big for people who are using data encryption. You could not use TDE in 2014. You can in 2016. So while there are still some limitations within In-Memory OLTP tables, a lot of them have been lifted in 2016. So here are the supported data types. The big change in 2016 is that you can implement varchar max. You could not do varchar max in 2016, but you can, in 2014, but you can in 2016. Bucket counts, the rule of thumb again for Microsoft is 1.5 to 2 times the number of unique values. What will happen if you have too few bucket values? It's going to negatively impact performance, and you don't want to make the mistake of having too many hash bucket values. You're not going to gain anything, and you're going to result in wasted memory. So 1.5 to 2 times, and you may want to run performance benchmarks to see what's the sweet spot. And again, in 2016, you can do an index rebuild when your bucket count changes. Getting close to the end here, so obviously you're going to be able to pull this slide on the slide deck and take a look at some additional notes. Store procedures in in-memory OLTP. You can actually have store procedures with native compilation, which is going to be compiled in the C language for additional performance. There were some limitations on native compilation in 2014. You could not do things like subqueries or union or select distinct in natively compiled store procedures that utilized in-memory optimized tables. That's been listed in 2016. Also, table valued parameters and table types, where you would be able to pass tables as parameters. That was something that was added all the way back in 2008. So you might create a table type structure and then pass values as a table to a store procedure. Again, that was added in 2008, but the main point here is that you can now specify in-memory optimized tables as a table type. So a reporting services scenario where you're trying to pass tables as values from a table as parameters to a store procedure for report, you might be able to utilize there. Okay, I'm out of time here. Yep.
Yeah, so I think we should thank you very much for a wonderful, wonderful presentation. We had some people asking, so as always, we record these sessions and we will upload them with the PowerPoint slide and demo code if relevant. So Kevin, you will send me that later and we will upload that into the group's archive page. So go to imvc@sqlpass.org, click on the archive tab, and there you can find a recording of this session, again, with the PowerPoints and the code. Okay. So thank you very much, Kevin.
Thanks again. Thanks for having me, and thanks to everyone for attending. Appreciate it.
Yeah, hope to see you again next month.
Okay.
Have a wonderful day.
Okay. So long, everybody.
Bye-bye.